Right. So hi all, for both those attending live as well as people who will be watching this recording later on. Welcome to Multimodal Weekly webinar series hosted by the team of 12 apps. So a little bit of context: we are a sister startup building multimodal foundation models we understanding, and this initiative is our work to spread more awareness around the category of multimodal AI. So we've been running this series every single Friday at 1:30 p.m. Pacific time over the past, I say 30 weeks. So here are some of the topics that we tend to cover, ranging from latest research in multimodal AI and foundation model, innovative application of multimodal in different verticals, some folks sometimes don't just share some of their own source project, for instance, related to work on generative AI, video AI, etc. Sometimes we have team members working on tutorials and guides on our platform and API. In some of the recent webinar series, we have a wide range of speakers. We have researchers talking about things like vision models to new architecture that can replace transformer. We have startup operator who talk about tools to embed such AI and open source file tuning, for instance. And sometimes also have like startup father who give talks about like things like application of AI in like film industry to insurance to animation, etc. So definitely kind of tackle a wide variety of persona. So today's talk we'll have Alex Bäuerle. Currently, he's working as a researcher at CMU, and he will give a talk about his project Zeno, which is a data visualization tools to help unlock model performance insights. I think I got connected with Alex like a few months ago and kind of take a look at the very initial prototype Zeno and just see like some of the capabilities of this visualization framework. And I think like even in the past, machine learning paradigm evaluation and visualization has already been a big problem because it's hard to understanding the output. And I think like given the recent movement in foundation model, large language model, and in the future multimodal model, I think the need for visualization evaluation is even greater. Yeah, so excited to hear Alex's perspective on what drive him to think about this problem and kind of the capabilities to address some of these challenges in the space. Yeah, so that's a quick introduction, and just a logistic note, feel free to enter your question in Zoom chat. Or I think like in this scenario, I think it's only Alex is the only speaker, then I think we can have a real time Q&A if needed, right? Yeah. So yeah, so that's my quick spiel on the logistical part. And yeah, Alex, why don't you get started with sharing your screen and talk about your work on Zeno. Oh, actually, you muted, so.
Super hard to find the Zoom overlay once you started sharing. Yeah, I'm very excited to be talking about Zeno today and to share some of our thoughts around how we think we should change in-depth AI evaluation to make it easier. My talk is going to be roughly like 50% about the state of AI evaluation and what we think about it. And then 50% we're gonna basically explore some data and Zeno together, and yeah, figure out what we can do with the platform. All right. So yeah, to get started, I just wanted to briefly introduce who we are. We're a team of interdisciplinary engineers, designers, and researchers at Carnegie Mellon. And so yeah, here are some of our faces, and the two people that are mainly behind the code that makes Zeno are the two Alexes at the top left, and then we have some designers, professors, students who are helping us engineer all of this. The way we develop AI systems has been streamlined significantly in the recent time, especially Just a few days ago, OpenAI opened its GPT store, or playground, where it's super easy to create these powerful assistants that can help you in specific tasks. And obviously this is one extreme, but here you don't even need like to write code really anymore. You can like prompt systems and put together some components. And that's all that's needed to kind of build these powerful assistants. And while the effort it needs to kind of create these systems is lowered every day by different libraries, the problem of how do we make sure that these systems are actually doing what we want them to do is not really solved yet. So the focus really shifts to making sure that these systems perform as we expect them to, evaluating them, comparing them. And the way we do this right now is we basically have these evaluation sets where we have some system input and some ground truth output, maybe some extra metadata for the evaluation. And then we feed these evaluation sets to the model and get some evaluation result back. And most of the time, this looks something like this, like a simple aggregate metric where we get something like an accuracy score. And we think that's fundamentally flawed because we have this rich evaluation set that has so much information, and then we're boiling it down to a single number that we don't really know how it's composed. And to illustrate this a bit more, you've probably all seen this before, these leaderboards. The most popular one is probably the one on the top left, the Hugging Face Open LLM leaderboard, where we rank all of these models basically by what score they achieve on these different benchmark tasks. And while you've probably all seen these leaderboards before, I wonder how many of you actually looked behind these leaderboards. Like how many of you know what, for example, the ARC or the HelloSwag challenge is and what the data behind it is. And I think too few of us really take a peek behind these aggregate numbers. And it's almost like we're hiring someone solely based on their IQ score or their university grade. Like we're not taking into account their personality or where they excel, where they're maybe a little bit worse than others. We're solely relying on like simple aggregate metrics. And you would never do this for a new hire, right? You would interview them, you would give them some tasks, maybe coding challenges. But what we do for AI systems, which arguably are employed nowadays in scenarios where we otherwise would have given tasks to coworkers or other people. What we do here is basically look at these aggregate metrics to understand the model performance, apply changes, or decide whether or not to deploy, which model to deploy. And so that's kind of the state that we do evaluation right now. Sometimes we do something like this, where we write some custom code, we generate some charts in like a notebook or something. But this is really one, it's I think the exception that this is done. And then two, it's not super reproducible. It's hard to change when like the system changes. It's not really shareable. You need like to transfer the data, make sure it's all in the right place and stuff. And so we think we need better interfaces to unlock the insights of model performance in evaluation sets. And this is where Zeno comes in. Zeno is an open source AI evaluation platform that helps you, one, explore your data, where you can like explore different slices of the data that you're looking at, really look in detail at the model inputs and outputs and what happens. You can compare different models against each other, look at what different outputs they produce, where they differ. And you can also create interactive reports that you can use to share with your colleagues or other people in the field to just share your insights about model performance. All right, so that's kind of the background of what we think where evaluation is and what we try to do. Let's now get a little bit to the fun part of this presentation. And this is going to start at hub.zenoml.com. You can go there as well and explore some data that we've uploaded or that other people uploaded. But I'm going to show you some examples and walk you through some of them, what I think are the most important steps in one of the in evaluation tasks. Step one is just looking at your data. And looking at your data can be as simple as just bringing up the data that you're using in your model, looking at it here. I have some 3D models. I have some annotations here in Zeno. When I did Thanksgiving post a while back where I searched for some turkeys in this 3D data set. And so, yeah, one is just important to look at the data behind your models. And while this is a very simple and kind of boring data set, there's no model outputs here, it can get very complicated in Zeno as well. So here we have a web arena task where the system is given some task to solve, and it can navigate the web to solve this task. So we have some screenshots from where the system went. We have like the URL, what it observed, like what actions it took, what information it extracted, and then we have some forth and back here. So it can get very complicated as well. But the important thing is we think you should really look at this, because otherwise, how are you going to know why your model is failing? And then we can also like use these subsets of data where where we filter by, for example, only the ones where the model was correct, was correctly solving the task. All right, so number one, please look at your data. Don't just look at the aggregate metrics. That's step one. I hope all of you are already doing that. Now, step two is quantifying the behaviors of your models. Like, it's not enough to just look at the data, look at some failure cases. What you should really do is systematically analyze what happens. And here I have another example. This is about a transcription model for different speakers here. We have some audio files that...
Please call Stella. Ask her to bring these things with her from the store.
It's just people reading these sentences. And then we have a model output that is basically the transcription of that text. And when I start exploring different models and what happens in here, I often start out with some performance charts. I've apparently been locked out before. No, we're back. Right. Where we compare different models against each other, and here we see the word error rate of these models. And so we see directly that like the medium-sized models, the blue here, they tend to have a lower word error rate than these larger-sized models, which are in red and green, orange and green. And I'm wondering why it happens. So what I'm doing next is I'm going back to this explore page where I see all the data. And I want to dig into these word error rate examples. And here I see, for this larger model that I just selected, I see that there's a suspiciously looking small bar here at word error rate 1.0. So I'm just going to select that. And what I see directly is that it should have transcribed to English, while actually it did transcribe to some Arabic script, which is not really what I expected. Let's listen in for a quick second.
Please call Stella. Ask her to bring.
Yeah, this is definitely not Arabic. So let's check out what's going on here. I'm gonna just really briefly check what happens here. So the model seems to actually kind of understand what the person is saying, but it's just outputting the data into the wrong script. So clearly this model is failing at identifying the right language rather than understanding the text that's spoken. And we can also go deeper here. So now I just look at the high word error rate examples. we can also see that maybe for Asian speakers, it tends to be worse. So we're probably interested in that subset of the data. And then also male speakers tend to apparently be mistranscribed more often. And so I can look at this data and I see, okay, there's a lot of Arabic going on here, but there's also some other Asian languages that are mistranscribed into the wrong script.
Please call Stella.
But they're definitely all talking English. And now what we can also do in Zeno is compare different models. So I've still selected this subset of data that I'm looking at. And let's look at one of the medium-sized models and maybe compare the word error rate. Okay. And here we see that while the larger models, like they fail on these kinds of examples, the medium-sized models, they're not multilingual, so they actually don't transcribe into the wrong script, which before like testing out this and investigating, I might have expected the large model to be better for my use case, but now I know if I'm maybe expecting a lot of strong accents for my application use case, then maybe I shouldn't use these multilingual models because they might mistake the language that people speak. I'm also going to show you one other example where we collaborated with Hugging Face on their new addition to the Hugging Face leaderboard. And they just a few months ago, they added two benchmarks to their leaderboard. One of them was drop. And this drop benchmark had some inconsistency in its performance. And we used Zeno to investigate more closely. And one thing that I want to briefly show you, we found a bunch of interesting insights. But one thing that I want to show you is a problem with floating point labels. So if we look at this, for example, the label contains a dot and a comma, but we see that the output is cut after, or there's no dot, no comma, and it seems like the output was stopped after the 99. Similar for the 80, here's a comma in the middle of the sentence where the rest of the sentence got removed. And it turns out after some investigation that the models were actually stopped, like the generation was stopped after this token was produced. So that the model never could have produced the correct label. And that led to the models performing very inconsistently on this drop benchmark. We then collaborated with Hugging Face on this nice article about it. And ultimately, the conclusion was to take down this drop benchmark from the OpenLLM leaderboard until this problem is obviously fixed. All right, so that was quantifying behaviors. And I hope this really showed you why this average statistics that we use right now often to compare different models or to evaluate their capabilities doesn't really work in a lot of cases. We don't know. We can't answer a lot of questions that we might have or need to ask for deployment. And we really need to go beyond these singular aggregate metrics to get a sufficient representation of model performance. All right, number 3, tell stories. We've made all these interesting findings, and yeah, we've learned a lot about the data. Now it's time to actually share that with our colleagues, collaborators, the broader community. So what we've also done in Zeno is we have this nice report builder where you can write your reports about your findings. So which can include things like markdown text. In this case, we're writing about the Google Gemini family of models, and this is a report about the code generation abilities of the model, comparing Gemini with GPT and Mixtral. And here we see the performance charts. we see some different charts about the length of the solution, where and how the models performed on these kind of different slices of data. And we can even display some of the examples that are in the data set. And when people read this report and want to explore themselves or learn more, they can just click on Explore and are directly in the Zeno project. They can explore all the data, create their own slices and everything. So yeah, that's how we imagine people should share the insights behind their evaluation results. For this Gemini project, we've even wrote a paper about comparing the Gemini models versus some of OpenAI's. Yeah, we ran a bunch of different benchmarks. When I say we, I must say mostly some other very talented people at CMU. We just help with the visualization part of it. But yeah, for each of these sections in the paper where we explain what we found, we also have this nice Zeno report now that really helps people like go into the data, learn a bit more about how we did our analysis, explore different types of data slices, and yeah, learn more about what we found, and then maybe even explore themselves further. All right. So that's number 3, tell stories, and we've taken a lot of inspiration from interactive data storytelling here. There is a lot of great work around this interactive data storytelling arch, especially on Distill, which is sadly on hiatus now. But yeah, we used our visualization background here to kind of integrate this interactive storytelling approach into Zeno to share insights. All right, so all together, I've been talking about Zeno today and how we think AI evaluation can lead to deeper insights rather than like the scratching the first surface that we often do these days. Zeno provides powerful tools for data exploration. We can slice the data in different ways. We can explore what the model produced and what it was fed. We can do that for different types of data, as you've seen. Like I've showed you 3D data, audio data, text data. And then we can compare different models on Zeno. We can not just explore the data, but we can also like, yeah, combat 2 models against each other and see where they differ, what they do differently. And finally, we can share our insights in interactive reports, which is yeah, really helpful to just distill our knowledge and bring it to other people in the community or in our project group or whatever we're working on right now. If you want to get started yourself and use Zeno for your own projects, it's super easy. We have this ZenoML.com website. You can get started. You can explore some of the projects that have been uploaded by other people. It's really easy to just a few lines of code to upload your data to Zeno and start exploring. Yeah, and so with that, definitely check out ZenoML.com. If you have any questions now or later, this is my Twitter handle. We're super interested in your thoughts around this area. And yeah, now I'm happy to take any questions, and thanks for having me.
Awesome. Yeah, thanks, Alex, for the succinct and very nice demo. Yeah, Matteo and Wendy, if you guys have any question for Alex, feel free to unmute and ask them right now. I think like for me, maybe I'm kind of curious a bit about your background and kind of the motivation on creating Zeno. So I think I did get a bit research on kind of your PhD background, right? And so you focus on basically visualization and explainability for neural networks. Right. And curious, a bit more, what is your focus of your PhD thesis, and how does that sort of motivate you to start this Zeno open source project?
Yeah. So my PhD thesis was focused around the visualization of AI systems or ML models. And I started out on like I guess smaller problems, and now like the last project I built during my PhD was also a platform for AI engineers to investigate their models and data and share insights in Jupyter notebooks. And I feel like the Zeno is kind of the culmination of everything coming together that I've been working on before, but now as something that is actually much more as a real product and more as something that people can actually use, rather than a lot of the research projects that we're working on during our PhDs are somewhat one-time use. So I think this is much more of a, let's take all what we've learned and like put this into an actual product.
Got it. So basically, like try to, instead of have a more like academic focus, to try to, think about adoption and make it more commercially available, right, for the broader public.
Exactly. Yeah. I mean, we're still helping people write papers and like get insights for research, but we're building something that's actually used by a lot of people. Like we have a much larger number of users in Zeno now than we had in any other of our research projects, and so this is basically the big difference. It's much more ready.
Matteo, do you have unmount?
Yeah, I mean, actually, I have a question for you, Alex. So first of all, thanks for sharing this. This is awesome. So I'm curious, since I guess that by building Zeno, you've been exposed to a lot of data sets and models. So is there like a common pattern, like a common mistake or a common insight that came over and over again, and maybe might be helpful for us, like as a practitioner, to be careful to like pay attention to that specifically?
Yeah, I guess so. Models are very diverse. I guess especially for data sets, we've seen a lot of evaluations happening on data sets that don't really represent the task that people are building for. Mm-hmm. So a lot of people like use these benchmarks that they find, but then when they look behind them, they're like not at all representing what they actually want to do. Like a lot of the benchmarks that are used for LLMs, for example, are multiple choice questions, where, I mean, I know very few applications of LLMs that result in answering multiple choice questions. So I think that's a big takeaway, that one, look at your data, but also make sure your data is actually representing what you want to do.
Okay, and there is an easy way I can do that with Zeno? Like, do you have like a specific visualization that you would recommend to spot those, like the mismatch between your like training or evaluation data set and your actual data set that you will use in production? Apart from maybe, I don't know, you mentioned the word error rate.
Well, I think Zeno generally just helps you like understand what you're even like evaluating on, looking at. We're not yet at a point where we're interested in helping you build the right evaluation set, but that's nothing that Zeno can help you with today. But that's definitely something that's super super interesting, because ultimately, if you don't have the right data to evaluate, even the best visualization might not help you. But without the right visualization, you're probably never going to notice.
Yep. Awesome. And last question, what kind of input data do you support? Like tabular data? I saw that there was like a screenshot from probably agents.
Yeah, exactly. So we actually have like a relatively flexible setup for data you can use. So what's happening? So we have this specification of how your instance view that you like see all these different instances in Zeno look like. And so you can like have images. This is for text classification, tabular, but then I showed you all the examples. I think you mentioned the reg where we like have multiple turns. Yeah, it's relatively easy in Zeno to kind of fit it to your own type of data. Yeah, we have like a code viewer. You can do like chat interfaces. So yeah, we have this view specification that lets you really define what data you're working with, because that's obviously one of the biggest issues that, yeah, we don't really know what task you're going to solve. But the task you're going to solve is really going to impact what kind of data you're working with. And we want to make sure that you can look at all your data.
Cool. I mean, this is awesome. Thanks.
Great. Yeah, I think when you click into the button of like explore, like, and it open up like a new Zeno dashboard, that kind of remind me of the interface with like, you know, Collab or, you know, Streamlit, right? Or just a very classic like notebook style computational. And I think like there's a couple companies out there that building solution for computational notebooks for visualization problem, but I don't think there's any one that actually like combine visualization with evaluation and design an interface that is specifically, you know, only for the solely purpose of like, you know, evaluation. So I think that is a very interesting take on like evaluation, I think from your point of view.
Definitely, yeah. I mean, yeah, I think we moved a bit away from the computational notebook world specifically, because we think that evaluation needs more interaction and more complex interfaces than you can reasonably provide in a computational notebook. Like this task of finding slices here and like looking at different models and comparing different examples. Yeah, I think doing that in a notebook just would be cramming it in. But definitely, like there's an overlap and a bit more. We've taken a lot of inspiration from the world of computational notebooks, how you get this data in and how you produce your reports for your findings and things like that. So definitely, and obviously, when you upload your data to Zeno, we definitely expect you to be either in a computational notebook or in your Python file, but probably most people will do this in a computational notebook, modify the data frame, and then upload it to Zeno.
Yeah, and I saw that I think in the past you used to intern at Google, right, and Apple, more specifically like Google's Pair and Google TensorBoard organization. And yeah, and these are like pretty popular product in space, like TensorBoard for I think the TensorFlow, you know, model visualization as well as Pair. I think they have a bunch of interesting work, I think, in the last few years on just the graphics part of AI. Can you talk a bit more about how that experience kind of shaped your motivate?
Yeah. I mean, both like Pair. I mean, TensorBoard is everybody knows that. Pair is an awesome research group inside Google that does a lot of visualization work around machine learning. They now have a language interpretability toolkit, which is really focused around language models. Which is, I mean, if you're interested in that, definitely check it out. Yeah, and I mean, I learned a ton there. We've been working on super cool projects. I think the project that's closest to Zeno that I worked on before was during an Apple internship where we worked on Symphony, which is going back to your computational notebook question, which is really focused around putting visualizations into computational notebooks. It's also been open source recently if you want to check it out. It's, I think, Apple ML Symphony or something like that on GitHub. Yeah, and yeah, I really, yeah, I can't say enough good things about them. So yeah, it's really yeah, they have awesome tools.
Perfect.
Are you taking any inspiration from weights and biases? Because definitely when you show the report, definitely reminded me of the weights and biases report as well.
Yeah, I mean, yeah, those reports, I think we took more inspiration from like the interactive articles, but I definitely see the connection to the weights and biases reports as well. I think generally weights and biases is more focused on monitoring of your model training process, less on like evaluating models on benchmark data sets. Yeah, but definitely, I mean, yeah, they're also visualizing.
Well, I mean, like now weights and biases is quite a big company, so they are kind of expanded like to cover other area. I mean, personally, I really like your like this idea of having like combining markdown, visualizations, code, etc. I think that's why I kind of really like weights and biases, because they allow me to first like monitor and log my like the training process, and then show it without like wasting days trying to export the data and visualize it somewhere else.
Yeah. And I think that's key. Like, you don't want to switch from the tool that you use and love to having to use something else to kind of share your insights that you made in that tool that's been super useful to you. So yeah, we think that this, not only exploring the data, but also sharing what you've learned about it, that's really critical for AI projects, especially.
Awesome. Great. I think maybe final question for before we close the webinar is it looks like, you know, the project is still pretty early, and I assume there's a lot more work in progress that you guys will be doing in the future. So yeah, what are something that you're most excited for Zeno, at least for 2024? Yeah.
So we've been thinking a lot about this, I guess, cold start problem. Like, Zeno is super awesome if you have evaluation data that you want to look at, but not everyone has like a benchmark data set ready to use that matches their use case. And so that's definitely something that we're looking into and interested in. And then also there's like the angle of automating the insights more. Like, I've not shown this to you, but we have like a slice finder tool here where you can automatically discover interesting slices of your data. And we're definitely also interested in like getting more of these features in, where right now you kind of have to like find your own slices, make your own conclusions. Maybe this Zeno could help you to discover actually the like failure points of your model, where it excels, where it underperforms. Also help you compare models, maybe even highlight if you add a new model, if it regresses on one of the slices that you've investigated before, and things like that. So yeah, those are definitely two areas that we're super interested in. Yeah, making error discovery more automatic, and also helping people to get started.
Yeah, I mean that makes a lot of sense. Just add it, kind of sticking to the workflow of the end users and build, you know, features / capabilities to address, you know, their pain points. I think that's a pretty logical approach to dealing with this problem. Yeah, so yeah, I'm excited to you know, follow the progress of Zeno and look forward to, you know, upcoming features released in the you know, in the rest of the year. The recording for this webinar will be available at some point, I think next week. And yeah, be sure to share it with on YouTube, so everyone here can access it, and as well as future folks who are watching the recording. And also include all the resources that Alex mentioned in the talk today to the show notes as well, so you can take a look and follow up, learn more. So yeah, with that, thanks guys for attending, and hope you have a great rest of the weekend.
Yeah, thanks, James, and thanks, Alex, and good luck.
Thanks.
Bye.
Bye.